turn the recording, and also I will share my screen. Okay. I hope you can see the screen. So the first questions are from 2020, third multiple choice question. Okay. We have to find all parameters of p is given. We should find all p for which the given integral is convergent. Okay. Is it a improper integral? Seems so. So it is. Say again. I cannot hear you. So this is a function which at 0 has a singularity point. So we should study the convergence at 0 point. What can we do? Think about our comparison tests, maybe direct, maybe limit comparison test. Near 0, what is the behavior of xp plus x2p? So it tends to 0, but what is the rate? Or limit or direct comparison test maybe is more convenient here. Do you have any suggestion? If no, I would suggest here to tackle with limit comparison test. So let's introduce. So here we have fx. This is f of x. And now let's consider gx as 1 over, help me, xp or x2p?
2p.
xp. Look, when we are considering limit at infinity, you are right. The highest term is the highest power of x. Near 0, the biggest term is x with smallest power. Let's check that this choice of g is correct, and also we will see that considering x2p will not work. Let's check this too. So we have to find limit as x tends to 0, f over g, 1 over xp plus x to the power of 2p divided by 1 over xp. And simplifying a bit, taking xp to numerator and dividing, factoring xp, we will get it is the same as 1 over 1 plus xp. So once again, xp jumps to numerator. We get xp over xp plus x2p. Simplifying by xp, both numerator and denominator, we'll get 1 over 1 plus xp. Now when x tends to 0, what is the limit here?
1.
Seems so. that limit is 1, but why so? Because xp tends to 0. But xp tends to 0 if power p is positive. So it's going to be 1 if p is greater than 0. I don't know whether it's important to consider other signs of p, like p equals to 0 or p being negative. Because in this case, we are not going to get here improper integral. Like imagine p equals to 0. If p equals to 0, we have 1 divided by 1 plus 1. It's a constant. It's not even improper integral. But keeping p positive, we get that the convergence of f holds if we have convergence of g. And for which p g is convergent? For p being smaller than 1. So power p should be less than 1 to get the convergence. So I would circle this as correct answer. Now imagine you have chosen g not 1 over xp, but 1 over x to the power of 2p. In this case, f of x over g of x would be x to p divided by xp plus x to p. And after like dividing by xp, we will get 1 plus xp. And when x goes to 0, p being positive here, the limit will be 0. And we can't, in this case, apply limit comparison test. So just LCT implies that the convergence here holds as p is less than 1. Actually, should we also be careful if p is negative or p equals to 0? No, because when p equals to 0 or p is negative here, we do not have even an improper integral, so there's no any issue with convergent. It is convergent. So it's typically we are using convergence of integral if it is an improper integral, but if you do not have any singularity point, it's more convergent than divergent. We'll call it convergent, which is correct, although it is not an improper integral. So for p being 0 or negative, also, of course, our integral is convergent. That's by link. Questions regarding to this exercise? Okay. If no more question, let me move forward and the next 8 one. We are given 2 improper integrals which are absolutely convergent. And which of the following integrals converge in general? Okay, so we know that from 1 to plus infinity, module f dx is convergent. Then what can we say about this remaining integrals? And also, yeah, we know that the convergence of module gx also holds. What can we say about the convergence of the remaining integrals? Please, do you have any suggestion? Which of the following? So we should find which of the following integrals is convergent. The remaining 4 are divergent. Can you see here some divergent examples? So to solve this example, guys, for example, to eliminate b, you can bring a counterexample. So it contains 2 components, gx squared and f root of x. Or to eliminate A, we can just bring an example of F, which is absolutely convergent, but this one is not convergent. It's not complicated, guys. Please help me. For example, if F is convergent, can we say root of F also is convergent?
Not in general. I don't
So
think
give
so.
an example for which it is not convergent. Give an example of F, which has absolutely convergent improper integral, but it's like root of modulo F is not convergent. Yes, you are right.
1 over x squared.
Perfect. 1 over x squared is a good example. Of course, 1 over x squared is absolutely convergent. It's positive, so yeah, convergent from 1 to infinity. But putting it under the root, we'll get 1 over x, which is divergent. So A is wrong. For B, we can use the same example as here and choose G something that is not going to create problems, like gx is also 1 over x squared. Why not? Then gx squared will be 1 over x4 convergent, but f root of x is still divergent. We can eliminate C by choosing this component divergent. Again, g1 over x squared. And guys, the convergence of improper integral is the result of the rate of our function, how fast it is decreasing. If fx is fast enough, you do not have any guarantee that root of x, g root of x, or f root of x will be faster enough. We are changing the rate. So here we do not have the convergence. In general, of course. D, yes, same examples here work. But Y is convergent. So we have eliminated four options. Why the remaining E is correct? Can you prove that if we have F absolutely convergent, then Fx squared will be convergent as well? How we can prove that this is convergent? Look, what we can do, so the only information we have is about Fx, not Fx squared. So to go to Fx, we can do substitution. What if we try x squared equals to u substitution? So if we think of this one, okay, of course, 2 dx is du. 2x dx is du. We do not have this x term we can multiply and divide. And if we perform the substitution, we'll get 1/2 integral fu du divided by root of u. Okay, and still we have from 1 to infinity integral. Why fu divided by root of u is going to be convergent? Because we can get the convergence, first of all, the absolute convergence, and how we can get the absolute convergence. Module fu divided by root of u can be estimated from above with root of fu. Because u is a number greater than 1, we are estimating from below by 1. And from above, we have fu function with module, which is convergent, since it's given that f in improper integral is absolutely convergent. So as a result, we can say that fu over root of u is convergent. So fu itself is fast enough. We are dividing fu, this small function, with the big number, so we are making it even smaller. So it is going to be convergent. Same with g also, gx squared. So f root of x is not convergent, fx squared is convergent. And why f root of x is not? Can we do substitution for this one? Maybe similarly we can get convergence. If we try to do this substitution, root of x equals to u. if we perform substitution, we will get something like we will get fu times u du, not divided. So it is bigger than fu function. Multiply and divide by root of x, we will get some constant times this. So the difference between f root of x and the fx squared is that here we have fu divided by u, so we are making our function smaller, and above for f root of x, after substitution, we'll get fu times u. We are going to make it bigger. Smaller function might be convergent, but bigger could be divergent. Questions?
Is C match DDX international?
Ne atnorit, eli?
C match DDX.
C match գրված է
DDX.
So fx squared, guys, fx squared can be convergent. This term can be convergent. But what can we say about g root of x? It still might be divergent, and convergent plus divergent for sure is divergent. So C is divergent because of this term. Vartan?
Ինքը հարցնում էր C մեջ DDX-ա գրած այդ
It's love chillers. DDX-ա գրած. Okay. So what does DDX mean? This D is a constant. And dx is this integration symbol. So D is a constant. Or there was a typo. I don't know which one is. More likely, of course, it's a typo, but it has no anything to do with the convergence, of course. It's divergent. You can say, what if this constant D equals to 0, then we have convergence? But it says in general. So in general means this constant can be anything. So ddx nezbanchika. So it's a type. Or D is a constant, and then we have dx symbol. Okay. Other questions? Let's move forward. We have multiple choice number 10. Find parameter P for which we have convergence. Mivaikan. The third example also was find parameter P for which we have convergence. And P was less than 1. P less than 1, we have convergence, so it should be -2 or -1. Then she. No. Can you help me how we can study the convergence of this series?
Ratio test of.
Ratio test of. Yeah, when we have factorials, let's try to apply the ratio test. Everything here is positive, Chair. Let's focus only these 5 options for P. P from -2 to 2. N minus P is going to be well defined because N starts from 5. So here everything is positive factorial, of course, of a natural number is positive number. Just consider N plus 1 factorial squared, and maybe it is better to write squared the product of two N plus 1 factorials divided by N plus 1 plus 2P. P is a parameter, it's just a constant factorial times N minus P plus 1 factorial. Okay. Divided by AN. Divided by AN, we can write on the numerator N factorial times N factorial and N plus P factorial times N minus P factorial jumps to numerator. Let's simplify. N plus 1 factorial divided by N factorial gives N plus 1. Another N plus 1 term, N plus 1 factorial divided by N factorial. Okay, done. Then we are going to have N plus 1 plus 2P factorial and on numerator we have n plus p factorial together. We will get n plus 2p plus 1. And also we have n minus p plus 1 and n minus p factorials together. It remains just n minus p plus 1. This is 1. Find the limit of this expression. Any suggestion? What is the limit of this expression?
1.
1.
We just get one.
Okay. Yeah, we have n squared term from numerator, the fastest term, and on the numerator we have also n squared limit is going to be 1. Unfortunately, it's going to be 1. What is the conclusion in this case?
No conclusion for us to
Yeah,
state.
we do not have conclusion. Ratio test was not successful here. Test is inconclusive. So we should try another approach. Let me clear this approach and move forward. Asik, other suggestion?
Կարողամ մի հատ term test անենք տեսնենք ինքը ձգտում է 0-ի թե չէ։
Okay, the term test or so-called the necessary condition for the convergence says that to get the convergence, at least we need, this is necessary, not sufficient, that n factorial squared divided by n plus 2p factorial times n minus p factorial should tend to 0. Okay, maybe we can eliminate some answers from this options for which the limit is not 0. Okay, how we can find the limit of this expression? To illustrate how it works, let me begin with this case. Just choose p and see what is the limit. N factorial squared divided by n plus 2 factorial times n minus 1 factorial. It gives, so once again, n factorial squared, we can write as n factorial times n factorial. And then group it as this term and the other one. So we will get n factorial over n plus 2 factorial gives 1 over n plus 1 times n plus 2. And from the second term, we have just n. It tends to 0. Perfect. But why are we talking about term test? Because it is just necessary condition. Now, can you answer to the following question? For p equals to 1, does our series converge? In other words, this is our general term. Series with this general term is convergent.
Պարտադիր չի որ convergent լինի։
Ավելի հստակ։ Պարտադիր չի, not the best way to describe. Is it convergent or not?
Doesn't it act like 1 over n?
Right, it behaves as 1 over n, and by limit comparison test, we can see that it behaves as 1 over n, and series with 1 over n is divergent. Okay.
I have a question for
Please.
this. If we're getting that an as դեպքում 0-ի ձգտած, չէ, convergent չենք կարա համարենք։
Չէ. Just tending to 0 is not enough. A harmonic series with 1 over n is a good example when limit is 0, but you have divergence.
Okay.
It is necessary, but not sufficient. So being motivated by this calculation, we can try to do the calculation for any general P. So n factorial divided by n plus 2p factorial and times n factorial divided by n minus p factorial. If we try to simplify as we did previously, second term n factorial divided by n minus p factorial gives n minus p plus 1, n minus p plus. So guys, yeah, at this point I'm considering p being positive, then we will discuss p being negative case. P is negative means n minus p is smaller than n. Hence, here we are going to get n minus p plus 1, n minus p plus 2, etc. up to n. On the numerator, we are going to get from these terms n plus 1, n plus 2, etc. And the last term n plus 2p. How many terms do we have here? Total number of terms from n plus 1 to n plus 2p.
2p.
2p. And how many terms do we have here?
P.
Here we have p. So all this stuff behaves as 1 over n to the power of p. So we can say if p is greater than 1, then we have convergence by a limit comparison test. Hence p should be chosen to love, but still we are considering only p being positive. What can we say when p is negative? Like -1, -2, these two cases also should be considered here. So let's try to use this space. P being negative. Let's consider p is negative, so p is something like -q, where q is positive. And now n factorial divided by n minus 2q factorial times n factorial divided by n plus q factorial. If we do the regrouping as we did previously, now the first term n factorial over n minus 2q factorial will give us terms on denominator and on numerator, and from n factorial over n plus q factorial we are going to get terms on our denominator. So numerator will contain n, n minus 1, n minus 2, so on, so forth, to n minus 2q plus 1. And denominator will start from n plus 1, n plus 2, etc. And the last term, n plus q. So we have, again, now on numerator, we have 2q terms, n to the power of 2q. Denominator will contain n to the power of q. So we can use term tests here to see that it tends to infinity, not 0. So it is divergent. No limit comparison test needed here. We need limit comparison test, or we can say that, yeah, by term test for negative p, p minus 1, minus 2, etc., it is divergent. Questions? Let me see if we have other questions from this test. No, that was all from 2020. So
Nihat հարց, եթե այս կարգի լուծումներում բացենք նշանը մինուսով, մենք միշտ անվերջ չունենք, չէ՞, ստանալու լիմիտը այդ ֆակտորիալների շնորհիվ։ Թե կարա ուրիշ արժեք լինի,
չէ, եթե p negative-ը միշտ ստանում ենք անվերջություն։ When p is negative, yeah.
Okay, merci.
Որտեվ numerator was n to the power of 2q, then numerator n to the power of q. Q is strictly positive or p is strictly negative. If p is strictly negative, it is going to be infinity. Okay. So we can shift to the other test, 2022. Okay. 8 and 10 multiple choice questions. We are given f continuous monotonic function 0 at 0, derivative at 0 equals to 2. How many of the following integrals are convergent in general? Okay. What can we say about 1 over f? Is it convergent in general for any f that is monotonic, 0 at 0, and derivative? Okay, guys, first question. Monotonic increasing or monotonic decreasing? What do you think? It's not given explicitly, right?
From this, maybe it's monotonic decreasing.
Why?
Aracın.
Why? 1 over f, or I'm asking about f. Do we know about monotonity of function f? It says only monotonic, right? Monotonic increasing or monotonic decreasing? This is my question. It's either always increasing, right? Or always decreasing. Because it says monotonic function. Now I'm asking whether it is always monotonic increasing or always monotonic decreasing.
It's increasing because the derivative is greater than 0.
Exactly. Thank you. So it says derivative at 0 is 2, which is positive number. And so at least in the neighborhood of 0, our function is increasing. Since it's always monotonic, so it's going to be monotonically increasing. I'm not sure that this is very relevant, but still.
Բայց մենակ կարանք ասենք, մենակ մի կետում որ անցյալ ունենք, այդ հերիք է։
Այդ հերիք չի in general, but մի հատ կետում եւ monotonic function added to that information, then it's enough. Monotonic function means it's always increasing or always decreasing. If we know that derivative at some point is positive, means in the neighborhood of this point, it's going to be increasing. But I'm not sure, once again, that this is super important for this exercise. Testing. Love, 1 over f. Is it going to be always convergent? Or you can bring me an example for which it is divergent.
Եթե մեր function-ը լինի x-ը, y-ը հավասար է x։
Y հավասար x չի կարելի, որտեղ այս պայմանը չի բավարարվի։ Ուրիշ բան ասեք, ոչինչ։ Y հավասար է x չի կարելի, y հավասար է կամ fx 2x 2x կարա լինի, կարա, որտեղ fx equals to 2x, okay, derivative at 0 is 2, fine, and f0 equals to 0. Okay, 1 over f, is it convergent? 1 over 2x, is it convergent?
Որովհետև մեկ constant դուրս կգա ու կմնա մեկ x-րդ։
Perfect. 1 over 2x is not convergent. We can eliminate. Which other options can we eliminate? Which one? First one, eliminated. Second one, is it convergent? 1 over x.
Եթե 2x քառոքսի վերցնենք, I think it can be convergent, որտև այս դեպքում մեծ կլինի։ Այս մեկից մեծ է։
Right, singularity point is 0 point. 1 over x squared is divergent. So we have eliminated this one. In the same way, we have eliminated this one. Right? So definitely we are going to choose in between these two options.
Եվ նույնիսկ ասեք երկրորդը ինչի ջնջեցինք։
if we are choosing fx is 1 over 2x, 1 over f squared is 1 over 4x squared from 0 to 1, which is divergent.
Ha,
1 over x squared is divergent near 0. Here singularity point is near 0.
Type 2-ը դրա համար չէ։
In the same way, we can't at this point say whether should we eliminate third or not, or the last one, because root of x is convergent, or cubic root of x is convergent. Now we should try to understand whether, like, let's begin with this one. Is it going to be convergent or not? Do you have any suggestion? Any hint? So here, the example fx equals to 2x is not a counterexample. Like having example is fine, but our goal is to construct, like knowing one example that works is not enough to say it is true in general. Okay? Okay. How we can study the convergence of this function, guys? How we can study the convergence of this improper integral? First of all, it is improper because f0 at 0 is 0, so we have trouble. 0 is a singularity point. Typically, we have comparison tests. We have limit comparison test. We have direct comparison test. If we try to apply limit comparison test, can we choose gx as 1 divided by root of 2x, or just x, doesn't matter. This 2 is not important. Why can we choose this g for our limit comparison test? Because limit as x goes to 0, f of x over g of x is fm göre. Guys, let me use another letter here. This age x, where this is our age x. So limit x goes to 0, we have a big root 2x over fx. Can you help me how we can find limit of 2x divided by fx? When x goes to 0, what is the limit of 2x over fx? If we plug 0, we have 0 over 0 form. If it is 0 over 0, L'Hopitalov. We can apply L'Hopital rule. Okay, let's continue. And yeah, we were very close to finish this exercise. Unfortunately, connection was interrupted. We spent our 40 minutes. So we should start from the beginning. What we are doing, we are trying to apply limit comparison test. We have chosen 1 over 2x under the root. And when we try to do the calculation, we have 2x over fx. 2x over fx limit as x tends to 0. And we said, yeah, limit can be calculated by L'Hopital rule. And applying L'Hopital, we'll get 2 over f prime x as x goes to 0. And f prime at 0 equals to 2. So limit here is 1. Limit here being 1 means we can apply limit comparison test. Hence, as we know, the improper integral of 1 over root of x or root of 2x is convergent, so this one is convergent. Similarly, here we can choose 1 over cubic root of x or 2x. And we can apply limit comparison test. Why so? Because, again, L'Hopital rule will help us to get the limit. So this one also is convergent. Hence, the correct answer is 2. Questions? If no, let's move forward. 2022 multiple choice number 6 also is a question from the chat. We are given parametric equation. Curve given with this y equals to t cubed plus t, x equals to t cubed plus 3t squared plus t. Our goal is to understand at which point, for which value of t, our tangent line will be parallel to y equals to x line. Two lines are parallel if they have the same slope. Now our goal is to find t, such the slope of the tangent line, which is nothing else than dy over dx, equals to the slope of this tangent line, which is 1. So we should find t for which dy over dx equals to 1. Dy over dx is derivative of t divided by derivative of x. So 3t squared plus 1 divided by 6t squared plus 6t plus 1 equals to 1. We have to solve this second order equation and find all t's. So it seems 3t squared plus 6t should be 0. Hence t equals to 0 and
Wow.
t0 and minus 2. This is the correct answer. Is it correct?
Քարտի համար ասը ես փոխանցեմ։
Հետո փոխանցեք էլի։
Ասի քարտի համար ասի տեղում փոխանցեմ ասը։ Տեղ վերանես փողը բահելու էլի։
Okay, let me mute the financial agent. Okay. Questions?
Իսկ այս tangent line-ի վրայով հարց կարա լինի մեր թեստի մեջ։
Good question. Չէ։
Մերսի։
Հաջորդ անգամ միջև լուծելը։ Չէ, կարա լինի final exam-ում, and I know that you are not only preparing for midterm 2 and also for final exam. So it is not waste of our time. 22-ից ուրիշ ինչ հարց կար։ Multiple choice number 7. Which of the following statements is false? We have convergence of series. This is the false statement. Do you agree that this is not true? 1 plus 1 over n to the power of n goes to e. Hence, this sum is not e, but is what? What is the sum here?
Infinity.
It's infinity.
Infinity.
Right, it's infinity because we have sum of numbers close to e. So yeah, it's going to be infinity. All right. The remaining options should be correct. The first one is quite similar. General term tends to 1 over E. Okay. Here we can check that it is telescopic. Similar to D, again, with the trick of telescopic series, we can find the value. And the last one is just application of infinite decreasing geometrical progression. Okay, 1/3 over 1 minus 1/3 gives 1/2. Should be true. So again, here, if you do not have this sum, instead of sum, if you have limit, of course it is correct, but it is sum, not limit. I think we are done with this test. So let's move to the 2023. Kam që tas nutës në hajë këtë. From 18, multiple choice 3, 7, 8, and 9. Third one. Find all values for P for which the improper integral is convergent. Our first very naive approach is if we just focus on infinity case and we say, okay, this behaves as the integral 1 over infinity 1 divided by root of xp or xp half dx, and it is convergent if p half is greater than 1, so p should be greater than 4, and we do not have this answer, and by saying, okay, something wrong, but spadł go. We have f.
Մեծա 2-ից որտե 4։
Ինչի 4-ից։
Vay. You are right. P is greater than 2. And P is greater than 2. Check. It is not as simple as this. Why this is not enough? Because, okay, this step is true, only at infinity. We studied only the convergent infinity, but x at 1 also is a singularity point. What can we do to get the convergence at 1? Now, split our initial integral from 1 to 2 and from 2 to infinity. And from 1 to 2, we have here improper integral xp minus 1 dx. The other one is convergent if p is greater than 2. Now, what can we say about this improper integral? We have difficulty at point 1. Right?
Yes.
So how we can study the convergent point 1?
Չենք կարա նորից DCT-ով estimate անենք։
DCT-ով առաջարկեք։
Էլի նույն ոնց որ ասած մեկը բարանակ x pi half։
Չէ, այսա տեսնենք ինչ չենք անենք։ DCT թե LCT նկատի ունեք։
Ես DCT նկատի ունեի։
Դե ոնց ենք estimate անում? Writing it is smaller or equal than or greater in Sense?
Չէ, սխալ եղավ։
Սխալ է, չէ՞, որտեվ this estimation is wrong. You can't just drop this -1. Այն չանենք, ժողովուրդ։ Near 1, can you help me how it behaves? So when p equals to 1, when x goes to 1, we have 1 to the power of p minus 1. 1 minus 1 is 0. So this is the reason that it's an improper integral and 1 is a singularity point. But how we can understand what is the rate of this expression at 0? For example, guys, if we have, this is just a naive, again, just one particular example, 1 over x squared minus 1. Can you say near 1, what is the behavior of this function? At 1, it is, again, yeah, it tends to infinity, but how fast? If we write it as x minus 1, x plus 1, it's done, right? Because x plus 1 at 1 is fine. So our 1 over x squared minus 1 behaves as 1 over x minus 1. Love, what if we have not x squared, but we have 1 over x cubed minus 1? How we can factorize? We can write x minus 1 times x squared plus, plus x plus 1. And again, so we can say 1 over x cubed minus 1 behaves as 1 over x minus 1 near 0.1. Can we say that whatever is p, we can compare this with 1 over root, since we have root, x minus 1. Can we apply limit comparison test? So we don't know whether this p is integer or not integer. If it is integer, it is easier. Maybe Newton binomial formula can be applied here to factorize. But when p is not necessarily an integer, it is going to be a bit complicated. That's why we are going to apply limit comparison test by choosing gx 1 over root of, and yeah, we know that p is greater than 2. This is already given from the second part. Let's choose gx is 1 over root of x minus 1. This is our f of x, and consider f over g. Under one big root, we will get x minus 1 over x p minus 1. And to calculate the limit of this expression, I suggest just focus on the limit of x minus 1 over x p minus 1 and find the limit as x goes to 0. X goes to 1. X goes to 1. Okay. When x goes to 1, we have 0 over 0 form. Hence, we can apply L'Hopital rule. If we apply L'Hopital, we'll get limit as x goes to 1. It's limit 1 divided by derivative of xp minus 1 gives p times x p minus 1. And when x goes to 1, it's going to be 1 over p. Just an integer, not 0, not infinity, if p is greater than 2. Or so we can apply comparison test. 1 over root of x minus 1. Is it convergent? The last question to close this page. Improper integral from 1 to 2, root of x minus 1. Is this convergent? Bones? Convergent? If you hesitate, do x minus 1 equals to t substitution, and you will bring your integral from 0 to 1, 1 over root of t. Once divergent chi.
Divergent-ը աստիճանը 1-ից փոքր է, այս էլ type 2 է, դրա համար divergent պիտի լինի։
Ամենից ճիշտը բացի վերջին կընտրությունից type 2-ը, աստիճանը 1-ից փոքր է, so it is convergent.
Ահա,
It is convergent. Whatever is p, it is convergent. So B was the correct answer. Find all values, p should be greater than 2. Okay? Okay. So 7, 8.
Բան ստեղից կարող ենք մի հատ multiple choice վերցնել նայենք։
6 է, este testi.
Հա։
Given a polar sector bounded by curve R phi, phi is from 0 to pi is 1. Okay. Can you help? What was the formula for area of polar sector? From 0 to pi, R
Squared.
each power.
Squared.
Phi.
Make
Yeah. Yeah.
Make
One
it
half. One half. I agree. So we know that this equals to 1. Moreover, the length equals to 2 pi. What is the formula for the length of polar curve? Integral from 0 to pi.
R քառակուսի գումարած R ածանցյալ քառակուս։ Արմատիտակ։
R squared phi plus R prime phi squared. P of phi equals to 2 pi. Okay. Which of the following statements is true? If we consider 2 times R curve, then the length will be 8 pi. So if R is multiplied with 2, what are we going to get? If R is going to multiply by 2, we will get here 4, and we are going to get here 4, and this 4 we can take out from the root, which gives us 2. So length will be just 4 pi, right?
It is wrong in this case.
Which means A is not correct. 2 times R, the area, if we multiply by 2, area will be 2 che. If we multiply by 2, R, so we'll get 4 coefficient here, and hence area will be multiplied by 4. It's not true. If we just consider R equals to minus phi, length equals to minus 2 pi. Okay, very funny. R equals to R phi plus pi. is 3 pi when phi belongs to minus pi to 0. Let's consider this case in more detail, like length of, now we are given the following curve. The domain is from minus pi to 0, and our r is r phi plus pi. So we'll get r squared phi plus pi plus r prime phi plus pi squared d of phi. And if we make here some substitution, phi plus pi equals to psi, we will get integral from 0 to pi root of r squared psi plus r prime psi squared d psi. So the length should be 2 pi. Actually, guys, when we are considering phi plus pi for polar coordinate system, it's nothing else than rotation. We are rotating our curve, and by the rotation, of course, the length is not going to be changed. Most probably the right answer is E. Let's hope it is the case. From minus pi half to pi half, yeah, again, it is pi half angle rotation. And after rotating, we are going to get the same area, yes. If we do not want to dig deep into this rotational things and just formula-driven result, yes, 1/2 r squared phi plus pi half d of phi. If we do phi plus pi half equals to psi substitution, psi now will be from 0 to pi, r squared psi d psi. Hence, it's 1. So the correct answer is E. Tav? Seven. We have two positive sequences. And we know that an plus 1 over an is greater than 1, and n over the root of bn is less than 1. Immediate conclusion from this part, without looking into answers, is that series with an is divergent, ratio test, and series with bn is going to be convergent by roots test. Hence, whether sum of these two will be convergent is wrong. It can't be convergent. Convergent plus divergent is divergent. Product. Nag. B and C. One says it should be convergent, the other one says it should be divergent. Can we say that so the correct answer should be from these two? Because maybe both in general is not correct. So give me an example when an times bn is convergent. Convergent means bn should be dominating. Like imagine our bn is, for example, 1 over n factorial. And an is 2 to the power of 2 to the power of n. This is fine. Of course, an plus 1 over an is just 2. So limit is 2 greater than 1. For bn, n of the root, it's going to be less than 1, it is convergent. This is convergent and it go կամ եթե կասկածում եք գրեք n not factorial but n to the power of n. So applying root test, of course, limit is going to be 0 smaller than 1. But product is, in this case, is convergent, hence C is eliminated. But changing the places, choosing our AN is 1 over, AN is n to the power of n and BN is 1 over 2n, we'll get that also this one is wrong. Now let's consider D and E. What's going on here? So once again, guys, how we have eliminated B and C. We know that series of AN is divergent. For example, it might be case because AN goes to infinity. BN goes to 0. Their product can tend to 0, can tend to infinity. We don't know. But for D, AN over BN, which one is correct? Convergence or divergence? Bn tends to 0. An maybe goes to infinity. An over Bn, guys, An over Bn is not like convergent, and let's prove it. Let's prove this. So we can construct an example to eliminate convergence, or let's prove the divergence. How we can prove that An over Bn is divergent? How we can prove this?
Չի ձգտում 0-ի։
It's most probably, բայց կարանք դա հեշտ չի ստանք, որ չի ձգտում 0-ի. Why as it if An plus 1 over An is greater than 1, what is our conclusion? That series is divergent, but we have something more. This actually, guys, if you remember the proof, implies that An tends to infinity. It's not only but the fact that it is divergent, but An tends to infinity. Bn tends to 0. So we have infinity over 0. Infinity over 0 is infinity. So this term goes to infinity, this term goes to 0, hence ratio goes to infinity, plus infinity if everything is positive. So E divergence is the correct conclusion. It can't converge never. Questions? Next.
Օրինակ որ այդ բինոսին ոնց որ ասենք որ չլինի, օրինակ բերելով, ուրիշ ձև չենք կարա անենք, եթե օրինակ չենք գտնում։
Like proving that this statement is wrong, proving statement is wrong. Whatever you can't prove, why not? Because you can't prove that whatever is B or C, this series might be convergent or might be divergent. You can't prove it in general. So any direct proof will not work. Hence, here we have just to bring examples. There's not any other way to prove that this, because it depends on cases. We can get An that tends to infinity, like slower than Bn. So examples here.
No, merci.
Բան էլի արշտամ, հիմա ստացվում է, եթե մեր մոտ այն divergent է, միանգամից ասում ենք, որ իր բանը հենց անդամը ձգտում է անվերջության։
Չէ, մենք ասում ենք սա. If we know that An plus 1 over An is greater than 1, this fact implies that An tends to infinity. If you just remember the proof of the ratio test, ratio test-ի ապացույցի մեջ անում ենք, որ An plus 1 ինչ-որ մեծա d, ինչ-որ n-ast Johnson span is assume d greater than 1, hence it goes to infinity, greater than something that tends to infinity. But your remark that knowing that series is divergent, can we say that the general term tends to infinity? Check. If series is divergent, still we can get an example when general term tends to 0, but series is divergent. Not the case here, not the case for root or ratio tests.
Okay. I see.
F, improper integral of f is absolutely convergent, which of the following? Very similar to some examples that we have solved together a few minutes ago. F has absolute convergent improper integral. Can we say that multiplying f with x, it is still going to be convergent? Of course, no. Like if f is 1 over x squared, by multiplying, of course, it's not going to be convergent anymore. B, C, D, E. Okay. If f is still 1 over x squared, putting instead of x root of x, it's not going to be convergent since the result will be 1 over x. Instead of x, if we plug logarithm even, it will be worse. Okay? 1 over logarithm squared x, of course, is not convergent. It's greater than 1 over the x, for example. Logarithm is lower than any power of x. It remains B and D, very similar example, fx squared or f squared x. What can we say here? Do you have any suggestion? What do you think? B or D is the correct answer? In few seconds or minutes, our connection will be again interrupted. Sorry. Yeah, sorry.
Your microphone.
The suggestion was x squared equals to u substitution, and we will turn the improper integral into fu. Then we have to multiply and divide by u will get divided by u du. And we can estimate module fu over u from above with module fu. And given the fact that its improper integral is convergent, we can easily get that B is correct. But why this is wrong? Please rejoin and we will discuss why f squared can be divergent, even if f is absolutely convergent. Come back.